So let's have a look at this topic here. So here we're going to be looking at some standard integration questions. So let's have a look at this first question here. How to integrate 2 cos x plus 3 over x minus square root of x dx. The first thing that we want to do here is to rewrite the equation in a nicer format that we can help us with integration. So for example, the square root of x can be rewritten in a different format. So we can rewrite integration of 2 cos x plus, we're going to leave the 3 over x as that, minus the square root of x can be rewritten as x to the power of a half. And we are going to integrate this with respect to dx. Means that we're integrating every x term. So in order to integrate 2 cos x, I like to have my own formula, my own way to remembering it. So that is by writing the sine x at the top and cos x at the bottom, and is going clockwise when we're differentiating. I know that we're integrating here, so integration is the opposite of differentiation, so we're gonna go anti-clockwise. So anti-clockwise give us integration, and clockwise gives us differentiation. So integration of cos x will give us, in this case here, sine x. So therefore that becomes 2 sine x plus integration of 3 over x. I can see that 3 over x is in the format of 1 over x ln 1 over x dx, which is ln x plus c, where x is the modulus. So in this case, I can rewrite 3 over x as 3 ln modulus of x. It's very important that you write as modulo of x, because ln can never be negative. And then the last term is x to the power of a half. So well, this is our normal integration, so we increase the power by 1, so it becomes x to the power of 3 over 2, as a half plus 1 is 3 over 2, and we're going to divide by the coefficient of x, which in this case is minus 1, so in this case become minus 2 over 3. And the last element here is the plus c. There we go. So that's your integration completed for this equation here. Nice and simple. So now let's have a look at the next question here. In this case here, we have to integrate cos x over sine squared x minus 2e to the x. So for this question here, feel free to pause the video and give it a go yourself before you see how we do this question here. So in order to integrate this, first of all, we can split the fraction as cos x over sine x times sine x minus 2e to the x. So I've rewritten that as it was, and the only thing I've changed here is the fraction. So now what we can do is we can combine them together. So cos x and sine x can be combined together to give us integration of cot x times by sine x is same thing as writing 1 over sine x, and 1 over sine x is the same as writing cosec x. And from there straight away I can see that equation number 7 is the one that I can use here to integrate, and still we have minus 2e to the power of x. So now integration of cot x times cosec x can be rewritten as minus cosec x, and integration of minus 2e to the power of x, the way that we do this is we differentiate the power, and differentiation of the power is 1 in this case here, so we have to divide it because we're integrating it, so we have to divide by the coefficient of it, so that will remain the same, which is minus 2e to the power of x. Then we have plus c, and there we go. That's the integration of the equation here. Moving on to the next question here, so we have to use this equation here to try to find the positive of constant of a in this case. So let's have a look on how we can do this. So we have to show that the integration of the left hand side is equal to ln 12, and we have to use this to find the exact value of a. So first of all, let's work on the left hand side on doing the integration here. So let's ignore the limits for the moment and let's focus on integrating it. So 2x plus 1 over x can be split down into two fractions as 2x over x plus 1 over x. The reason this can be done here is because in order to add two fractions, we must have the same denominator. And so this is a reverse engineered to find that. So now we have to simplify it, and then we have to integrate it with respect to dx. So 2x over x becomes integration of 2 plus 1 over x with respect to dx. Integration of 2 is simply going to be, we don't need to write the integration sign anymore, so that's going to be 2x plus 1 over x. We know that that's going to be ln x and plus c. So that's our integration done here. So we can apply the limits. The limits in this case here, 3a and a. So let's substitute in the limits. So that becomes 2 bracket 3a plus plus ln of 3a plus c minus the lower limit. So that becomes 2 brackets a plus ln of a plus c close bracket. So we can see the plus c and plus c cancel out. In fact, whenever you're substituting the limits, we don't need to include the plus c because they cancel out anyways. So I've just put it here just to, for the sake of completion. So in this case here, that simplifies down to 6a plus ln 3a for the first part. And from there, we are subtracting 2a plus ln a. So 6a minus 2a, that will give us 4a plus, and in this case here, we have ln 3a minus ln a. So using the laws of logs, so if you have ln a minus ln b, that becomes ln a over b. So this equation here becomes ln 3a over a, and this will simplify down to now as 4a plus ln 3 as the a and a cancel out. So now we found a simplified answer. So now what we can do is we can take this and we can equate this to the ln 12, which is the answer they said they get. So 4a plus ln 3 is equal to ln 12. So from here I can take the ln 3 to the other side. So therefore that becomes 4a is equal to ln 12 minus ln 3. I can apply the laws again. So 4a becomes equivalent to ln of 12 over 3. And that way it becomes 4a is equal to ln of 4. And the value of a from here becomes a is equal to a quarter ln 4. And this here is your final answer for the value of a in exact value. So we've done the first 3 questions. So the next 3 questions are there for extra practice. So hopefully you understand and the process behind on how to do it, and you can take that and implement it in order to answer the next 3 questions. So again, feel free to pause the video and give it a go if you want to give it a go yourself first, which I highly recommend. And then you can check for the solution here as I go along. So here we have integration of 1 over sine squared x plus 1 over x dx. So first thing that I can do here is rewrite this in a different format, especially the 1 over sine squared x. So this can be rewritten as integration of 1 over sine squared x can be rewritten as cosec squared x. And the reason I've done this, because I know there is nothing I can do to integrate 1 over sine squared x, but I can change the format to cosec squared x, which I can see that will be equation 8, which I can use to integrate this. And plus 1 over x will stay as it is. And again, we're integrating this with respect to dx. So integration of cosec squared x is simply going to be minus cot x plus integration of 1 over x, we know is going to be equation 3, and that'll be plus ln modulus of x. As I said earlier, ln can never be negative, so therefore we have to put the modulus sign next to it, and that'll be plus c. And therefore this is the integration in this case here. Again, feel free to pause the video and give it a go yourself. Otherwise, just follow along here to see how I do this question here. So in this case, again, we have 1 plus sine x all over cos squared x plus cos squared x sec x. And we're integrating this with respect to x. So first of all, I can split down this fraction here into 1 over, again, we're integrating, so it'll be 1 over cos squared x plus sine x all over cos squared x plus, in this case here, I can rewrite the cos squared x as cos squared x. There's nothing to simplify, but the sec x, I can rewrite it into a different format as 1 over cos x. So, in this case here, the 1 over cos x, I can look at, by looking at the equation on the right hand side, I can see this is sec squared x. So I can rewrite 1 over cos squared x as sec squared x. Again, we're still integrating. Then we can do plus, and we can split this fraction, the second fraction, even further, and we can split this down into sine x over cos x multiplied by 1 over cos x. So I split the denominator into 2 cos x like that, and that'll be plus, in this case here, cos squared x times by 1 over cos x. So 1 of the cos x will cancel out with that, so that'll be plus cos x. Again, we're integrating with respect to x. So I haven't done any integration yet. I'm just been rearranging it and rewriting this equation in a nicer way so I can work with it. So in this case, again, we have integration of sec squared x plus sine x over cos x become tan x, and 1 over cos x that become sec x plus cos x dx. So now is in a much nicer format that I can integrate it from there. So I know the integration of sec squared x is simply going to be tan x. Plus I know that tan x and sec x, it becomes sec x. So it becomes plus sec x for that part. Plus, and I remember the diagram that I showed earlier, if I have sine x at the top, cos x at the bottom, clockwise we're differentiating, anti-clockwise we're integrating. Integration of cos x gives me sine x will be plus sine x, and the last element is the plus c, which is the constant. And that's the answer in this case here. So here we are for the last question of this video. So I strongly encourage you to pause the video and give it a go to this question here from the knowledge that we have built so far. This is very similar to the third question that we did, but let's have a look on how we can do it. First of all, we're going to focus on integrating this, and then after that we can equate it to the solution to find the exact value of a. I'm going to ignore the limit for the moment, so that becomes integration of 3x minus 1 all over x. So I can split this into 2 fractions, so it becomes 3x over x minus 1 over x, and that will simplify down to integration of 3 as x and x cancel out minus 1 over x. And again, we're integrating this with respect to x. Integration of 3 becomes 3x, and integration of 1 over x becomes minus ln x. As I said earlier, because we are applying the limit here, there is no need to include the plus c, but if you're not applying any limits, then include the plus c. But this is our integration done. So the next thing that we need to do is substitute in the limits that we have here, 2a and a. Substituting the limits gives us bracket 3 bracket 2a minus ln 2a minus 3 bracket a minus ln a close bracket. So if you simplify this down here, so that becomes 6a minus ln 2a minus 3a minus ln a. 6a minus 3a gives me 3a, and here I can rewrite this ln in a different way. So minus and a minus ln gives me positive ln a, and then I have the minus ln 2a. This can be simplified down to 3a plus, again applying the ln laws. So if I have ln a minus ln b, that becomes ln a over b. So I can rewrite this as ln a over 2a, and this simplifies down to as 3a plus ln 1 over 2. So this is my answer simplified, as the a and a cancel out. Now we can equate this to 6 plus ln 1 over 2. What difference can we notice between these two different equations? The ln 1 over 2 is in both equations. The only thing that is different here that we can see is the 3a and the 6. So you can equate them to solve and find the value of a. So now we have 3a is equivalent to 6. So from there, if you rearrange for a is equal to 2. And that's your answer for this question here. Hopefully you found the video useful. Please do share with one of your friends that will be useful for them for them as well. Subscribe and like and comment for more videos like this. I'll be focusing on integration for the next few videos. So we have a couple of videos on integration. Thank you.